Right now, engineers are digging trenches and boring tunnels across entire countries to bury a new kind of power line so deep you'll never see it. And this hidden network might be the single thing that decides whether the switch to clean energy actually works. Here's the problem nobody puts on a poster. We're building wind farms in the windiest places and solar farms in the sunniest ones. And those places are almost never where people actually live. The wind screams across the north of Germany. The power is needed in the factories of the south, hundreds of miles away. Build the turbines and you've solved nothing if you can't get the electricity to the people. That gap between where clean power is made and where it's used is one of the biggest, least talked about obstacles to the entire green transition. And the fix is being buried underground as we speak. So in the next few minutes, I'm going to show you 3 things. Why the ordinary power lines you see on towers can't do this job, and what's quietly replacing them. Why they're spending billions to put these lines underground instead of just stringing them up in the air. And the strange political fight that's pushing this whole revolution beneath the surface, out of sight. Most people won't notice this shift until it's finished. You're seeing it while the trenches are still open. If you like the massive hidden systems the modern world runs on, hit subscribe. It genuinely keeps this channel alive, and that's the only time I'll ask. Let's get into it. Start with the wires themselves, because the ones we've used for a century have a fatal flaw for this task. Almost all the power lines you've ever seen carry alternating current, AC. It's brilliant for moving electricity around a city or a region. But push AC over very long distances and it starts leaking energy, bleeding power into the air the whole way. Send wind power a few hundred miles on old-fashioned lines and a chunk of it simply vanishes into heat before it arrives. For a grid built on local power plants, that never mattered much. For a grid that suddenly needs to haul clean energy across an entire continent, it's a deal breaker. The answer is a different technology with a confusing name: high voltage direct current. HVDC. Same direct current idea as a battery, cranked up to enormous voltage. And its superpower is exactly what AC lacks. It moves gigawatts of power across vast distances while losing very little along the way. Over long hauls, HVDC is dramatically more efficient. That's the whole reason it's becoming the backbone of the clean energy grid. When distances get big, beyond a few hundred miles on land or even short stretches under the sea, HVDC wins, and it isn't close. And once you can move power that far, that cheaply, something powerful happens. You can link entire regions together, which turns out to matter more than almost anyone realizes. Here's the honest part, because I won't oversell this. Underground cables don't magically fix the fact that the sun sets and the wind drops. That problem, intermittency, is real, and it mostly gets handled by giant batteries and by shifting when we use power. But HVDC attacks it from a different, clever angle. It's about geography. The wind is always blowing somewhere. The sun is always shining somewhere. So if you can cheaply connect places that are far apart, a calm evening in Germany can be covered by hydroelectric power flowing in from Norway. A cloudy week in one country is backfilled by sun in another. Look at Germany's SuedLink project, a roughly 700-kilometer line built to carry northern wind power south. And notice it ties into a sub-sea link to Norway, so that when the German wind dies down, Norwegian hydropower can flow in to fill the gap. You're not storing the energy, you're borrowing it from somewhere the weather is better. Spread your grid across a whole continent, and the ups and downs start canceling each other out. One region's shortage becomes another region's surplus. That's the quiet magic of long-distance transmission. And it's why these cables are being treated as critical infrastructure, not just wires. But here's the strange twist. Instead of stringing these game-changing lines up on towers where they're cheaper and easier to build, they're burying them deep. And the reason why says something uncomfortable about how we actually build things now. You'd think the hard part is the engineering. Often it's the people. Try to build a big overhead power line across populated country, and you hit a wall of opposition. Nobody wants a line of steel towers marching across their view, their farmland, their town. The lawsuits pile up. The permits stall. Projects that should take a few years drag on for a decade or die completely. Planners have a grim nickname for it. And it's one of the biggest hidden brakes on the entire energy transition. The technology is ready. The politics are not. So the workaround is to disappear. Bury the cable in a trench or bore a tunnel straight through the rock, and the objection largely evaporates. No towers, no view to ruin, far less to fight. It costs more, it's harder, but it gets built. Germany's SuedLink, once finished, is set to be the largest underground power cable in the world, at a cost in the region of $11 billion. And it went underground in large part to get past exactly this resistance. And this isn't just a European quirk. In late 2025 and into 2026, grid planners in the United States looked at a major new link in Virginia and chose an all-underground HVDC line, even though cheaper overhead alternatives were on the table. Read that again. They picked the more expensive buried option over the cheaper towers because the buried one could actually be built without a war. When more expensive but possible beats cheaper but doomed. You understand the real constraint isn't money or physics. It's whether the neighbors will let you. Once you start looking, the scale of what's being built out of sight is staggering. Under the Tyrrhenian Sea, engineers just laid an HVDC cable more than 2,000 meters deep, a world record, to knit Sicily, Sardinia, and mainland Italy into one renewable sharing grid. And the truly wild proposals go further. There's a plan to run thousands of kilometers of cable from solar and wind farms in Morocco all the way to Britain. Another to send green power from the Australian outback across the seafloor to Singapore. A line thousands of kilometers long. These are among the most ambitious pieces of infrastructure humans have ever attempted, and most of them will end up buried in trenches or sunk on the ocean floor, completely invisible. You will never see them. You'll flip a switch and clean power will arrive. And you'll have no idea it traveled hundreds of miles through a cable in the dark to reach you. That's the point. The most transformative energy infrastructure of our lifetime is being deliberately built where no one has to look at it. So here's where it leaves us. The clean energy future doesn't just depend on turbines and solar panels, the glamorous stuff everyone photographs. It depends just as much on an unglamorous, invisible web of buried cables quietly stitching continents together. So the wind in one place can power a city in another. You'll never see this backbone. But every time clean power reaches you smoothly without a blackout, it'll be partly because of a cable buried somewhere beneath your feet, doing its job in silence. If that changed how you picture the energy transition, subscribe. This is exactly the kind of hidden machinery I dig into. So here's my question for you. Should we accept the higher cost of burying these lines everywhere to get them built faster? Or is that just letting a vocal minority force a more expensive grid on everyone? Tell me where you land in the comments.